2 paper that you've been set. Question 1 is about Kevlar. Explain what is meant by the words in bold in the above passage. You just need to look these up in the textbook and make sure that you know what they mean, because you are quite often asked those kind of questions. Part B asks you to calculate the maximum force which can be exerted on a single strand of Kevlar. To do this, you need to remember that stress equals force over area. What you're interested in this case is the force. You are told the braking stress. Note the area is given by pi r squared. In the table they give you the diameter, so if you've not divided that by 2 you'll get the wrong answer. And also notice that it needs to be in meters. You need your area in meters squared, or else again you won't get the correct answer, or you won't get the answer in newtons. Part C of this question, you just need to remember that the Young's modulus equals stress over strain you know the Young's modulus, you know the braking stress, so you can work out the strain. You should get an answer for strain of 0.015, and then if you remember, of course, that strain is change in length over original length, so strain equals, you should be able to work out what the new length, what the extension was in this case here. Part C, Kevlar's a polymer. What's a polymer? Look it up in the book. Question 2. In an experiment, 2 lenses, one diverging, one converging. Well, you get a real image here. So if you get a real image, obviously the converging lens must be the stronger of the 2. Must have the greatest power. When you look at the graph here, you just need to apply y equals mx plus c. This is an experiment that we actually did in the classroom, so you shouldn't have too many problems with this. You should find that the gradient is -1 and the intercept is 10, and so from that you can use y equals mx plus c to write down the equation in this case, although clearly it won't be y and x. You need to look at what the values are on the graph for the y and the x axes. The power of the lens combination is actually given by the y-intercept in this case. Notice that power of lenses is measured in diopters, or meters to the -1, and that powers add. So if the converging lens has a power of 20D, the answer to part C is 10D, then the power of the diverging lens must be such that 20 plus the power of the diverging lens equals 10, minus 10 diopters. Part E, you just need to draw a ray diagram. There are marks for drawing all 3 of the rays through the centre of the lens, parallel and through the focal point on the other side. Note that the focal length of the converging lens is 5 centimetres in this case. It corresponds to a power of 20D. And if you draw the diagram correctly, you should get the distance from the lens to the screen of about 6.5 to 7 centimetres. Question 3, what's meant by the work function? Look it up in the book. Explain the production of this current. You just need to talk about what photoelectricity is. Photons arrive at the metal, their energy is transferred to electrons, the electrons leave the metal, and you need to obviously clearly say what an electric current is, moving electrons. Part C is pretty fundamental to the understanding of the photoelectric effect. If you increase the intensity of the light, one thing will happen. If you increase the frequency of the light, something different happens. If you are not able to answer these questions, you need to read the textbook, because that's fairly fundamental to understanding the photoelectric effect. Part D, E equals HF is the equation, although note here they give you the wavelength, not the frequency. So you need to either work out what the frequency is or just substitute in the equation here and plug the numbers in. If you do that, you should get an answer of 4.7 times 10 to the minus 19 joules. Part E, you need to turn your answer for part D into a value in electron volts, and then if the photon arrives with, if the work function of sodium is 2.7 electron volts, and you work out the energy of your photon in electron volts, it's greater than 2.7 electron volts. So if the photon turns up with more energy than the work function, there will be energy left over, and that will be translated into the kinetic energy of the electron. And the maximum kinetic energy answer you should get is 0.26 electron volts if you do the sums correctly. Part F, why does reversing the potential difference reduce this current? If you reverse the potential difference, then the electron, not all the electrons will reach the anode. The low energy electrons, remember the value calculated above is the maximum kinetic energy. The low energy electrons will never get there, so they won't be able to flow in the wires and cause a current to flow. And part 2, the answer is 0.26 volts. If you remember your answer to part E was 0.26 electron volts, make sure that you understand why the answer to part 2 is 0.26 volts.